Next, we're going to look at rotations in section 3. I'm not going to ask you to draw rotations. I'm just going to ask you to write the coordinates of new shapes after we rotate on a coordinate plane. So a couple things. We're going to have what's called a center of rotation and an angle of rotation. Our center of rotation is always going to be located at the origin, so 0, 0. And our angle of rotation is either going to be 90, 180, or 270 degrees. So your rules that you're going to want to get written down on your sheet of paper: for a 90-degree counterclockwise, xy becomes negative yx. For 180 degrees, xy now becomes negative x, negative y. And then for a 270-degree counterclockwise, xy is now y, negative x. Notice how I'm always saying counterclockwise. If you were to go clockwise, you're going to be in a little different spot. If I would say I'm rotating 90 degrees clockwise, I'm actually at 270 degrees counterclockwise. Right? It's just the opposite. 180 is always 180. And if I went 270 degrees clockwise, that would be 90 degrees counterclockwise. If they don't tell you, assume counterclockwise. Okay, so looking at this example in here, it wants me to do a 90-degree rotation about the origin. Okay, so my rule, really quick, xy becomes negative y x. So p prime 1, 1 is now going to be negative 1, 1. Q prime is now going to be negative 5, 4. And Q prime, R prime is going to be negative 1, 5. For 180-degree rotation, I'm just going to do 2 of these points, I think. I'll do G and H. XY is going to become negative x, negative y. So G prime is going to be at negative 7, negative 1. And H prime is going to be at negative 6, 3. Your last one, 270 degrees. Your rule, xy is now y, negative x. So M prime is going to be 3, 6. P prime is going to be 3, 2. Q prime is going to be negative 2. Q prime is going to be at y, x, negative 2, 3. And V prime is going to be at negative 2, 7.